10.2, Simplifying Radicals, Algebra 1. This is where we start simplifying some of those square root signs we've looked at before. All right, so let's get started. All right, a radical expression is an expression that contains a radical or a square root sign. Square root sign, okay? A radical expression is simplified when there are no fractions under the radical sign, there are no perfect squares under the radical sign, and there are no radicals in the denominator or of a fraction. So when we're simplifying, there's a few steps you have to look at. First, you're going to look for perfect squares or cubes, okay? Those are kind of things like 36, or perfect cube would be this, because 36 is 6 squared, and 8 is a perfect cube of 2. Okay, so when you're doing these perfect squares and perfect cubes, if you need to, write over to the side of your paper, what's 1 squared, 2 squared, 3 squared, 4 squared, etc., etc. And that's the numbers you're looking for, 1, 4, 9, 16, etc. Same with the cubes, except for it'll be 1 cube, 2 cube, 3 cube, and so on and so forth. Okay, you're looking for those perfect squares or cubes. We're going to do prime factorization trees. It'll help you out a lot. And then you can factor the constants into prime numbers, which I'm going to show you. Group variables in pairs, and if it's under a square root sign, you group in pairs. If it's under the cube root sign, you're going to group in triples. You're going to bring the constants out and the variables out from underneath that radical sign in groups of 2 if it's a square root, groups of 3 if it's a cube root. And then you're going to leave all the ungrouped factors under the radical symbol and then simplify. I know it sounds a lot like a lot of stuff, but let's just look at some problems, okay? All right, for example, you have the square root of 18. What you want to do is make it into prime factorization trees. So you'll take 18, and you start on the top, and you will want to use the prime factors. That starts with 2 and goes to 3 and then 5. Okay, 2, 3, and 5 are the most common ones used. And you're going to want to put the prime numbers to the left. So I started with a 2 because this is even. So I started with a 2. So I took out 2 and I said 2 times what is 18? That's 9. Okay, so 2 and 9. Then you prime factorize that because 2 is prime but the 9 is not. That 9 breaks down to 3 and 3. When you're done, you circle the pairs because this is a square root sign. That means it comes out in pairs. And then the pair comes out of the square root sign. And then what's left that's prime goes inside. Okay? Something else to help you remember, in the radical sign, and I know we talked about that earlier in the year, if there is no number in the little hook of the radical sign, that's called the index. There's no number there, it's considered to be a 2. So that's why you take out pairs, okay? All right, so this one is now factored and, taken out and simplified as far as it can go. So the square root of 18 becomes 3 square roots of 2. Now you can check that because if you take whatever you put outside and square it, that's going to be 9. 9 times 2 is, 9 times 2 is 18, and that's what we started with, okay? So you can check your answers. All right, so let me try the next one. You may have variables also in there, okay? They have to be in pairs also. You can just break them apart and take them out in pairs. So for example, using the 18 again, I'm going to break 18 down. That's going to be 2 and 9, and 3 and 3. Take a pair out. That's 3, square root of, and then 2 is left inside. The prime numbers go in. And don't put this in there, because that needs to be broke down. All right, so it's 3 square roots of 2 right now. I also have a to the third, which is really a times a times a. All right, because I'm working with square roots, I need to take out a pair of a's. one pair of A's. So that's just one pair of A's. The leftover one goes in the house. So this simplifies to this. Now, if you wanted to check your answers, again, square the 3, 3 squared, and A squared times 2A, okay? 3 squared is 9, A squared is A squared, times 2 times A will make 18A cubed, okay? So you can check your answers. So this is my final answer. Let me make it red. Okay? That is my final answer on that one. Now, when you're working with radicals, okay, if you ever come up with a negative underneath the radical sign, you cannot do that in Algebra 1. This is no solution kind of thing. Okay? You cannot do that right now. You'll be able to do it later, but right now you can't. If you get that negative under there, just stop. You don't break it down at all. You just say no solution. Okay? All right. Another example is the cube root. So we have to do cube roots too. But when we're doing cube roots, we're going to be looking for groups of 3. So I'm going to still take the middle number, the number under the radical sign, which is called the radicand. Okay, and I'm going to break it down using prime factors. Starting with this, I look at this and I see it's even, so I'm going to start with a 2. So I'm going to take a 2 out, and then I'm going to have 32 divided by 2 is 16. Okay, 16 breaks down to 2 and 8. 8 breaks down to 2 and 4. And 4 breaks down to 2 and 2. Now, because I'm working with cubes, I have to have groups of 3. So I'm going to circle a group of 3, and that's going to come outside of my radical sign. And leave that little 3 in there. It's important. You have to have that 3. It means a totally different thing than a square root. And then whatever I have left over, I have this mess right here. That's not a group. You multiply whatever's left over together. So it's 2 times 2, which is 4, and that goes in the radical sign. Okay? So that is 2 cube roots of 4. And that will make, if you wanted to multiply that out, 2 times 2 times 2, remember this would be cubing that, so that would be 8. All right? Cube roots of 4. 8 times 4 is 32. Okay? That's how you get and check your work. All right? Now, you could also have variables under the cube roots also. Now, when you're working with things that are already in this format, and are already in this format where there's a number already outside there, you will multiply to it. So, for instance, if I gave you the 2 times the square root of 16, no, let's make it 160. Well, let's just make it 16 for now, okay? 2 times the square root of 16. Square root of 16, you break it down, 2 and 8, 2 and 4, 2 and 2. Okay, you want pairs, there's 1, there's another pair. You multiply these pairs together, so that's a 2 times 2, which is 4. So the square root of 16 is 4, there's nothing left over. So the 4 comes out and multiplies to whatever's already out there. So this answer would be 2 times 4, which is 8. Okay? So whatever's already out there, if it comes out, it multiplies to that also. Okay? All right. You may also have a problem that looks like this, a big radical with a fraction underneath it. And we just talked about how you can have a radical with fractions. Okay? So you want to split this apart. Whenever you see a big square root like that, you can break it into 2 radicals that look like this. All right? And then that breaks down nice and easy because what's the square root of 36? 6. What's the square root of 49? 7. So this simplifies to just 6 over 7 with no radical sign, okay? So look for those perfect squares. You can rewrite this so you write it like this if it helps you. Okay, that's the same thing. These are exactly alike. We just rearrange it so that we can work with it easier. Okay? I believe that's all we have. So we will practice a lot more in class. And if you have any questions, come see me.